inside. So I'm still I like to talk. Don't mind my look, my look does change. Probably when my hair is grown or I bring it out. Anyway, so this morning we're going to be taking a look at these questions that we have here. So MTS 101. It said that prove that if A and B are two sets, A union B is equals to into this close bracket A minus into bracket A intersection B, then union into this close bracket B minus A intersection B, union into A intersection B. So we are going to solve this first one. Alright, so I want you to get along with me. I'll be solving it. It's not very hard, it's not. So alright, solution. Alright, so this one we want to prove this question one. So I want you to just suppose that, okay, suppose you have to suppose that, or you can admit that A union B is equals to A intersection B prime plus A prime intersection B plus what? Then plus A intersection B. Okay? So, and most likely you know very well that union tends to what? Tends to plus, intersection tends to what? Multiplication. There's no stress about that. Alright, so at this junction, we now have that. Now, you might be asking me that how did I came about A intersection B prime and A prime intersection B? Where is it coming from? Alright, so let me explain that with a diagram. So if we have this kind of table like this, let this be my A union B. I am using two sets. Okay. So if this circle is meant for A and this circle is meant for B, regardless, the two are joined there. So their intersection is between them. Okay. So now if I shade this one like this, if I shade this one, I shade this like this. Okay. I shaded A, I didn't shade A. Why? So, and what is needed for B? This one is not yet up to this until I shade it. So I shaded A, I didn't shade B. So what is needed for B to match with A? What's needed for B to match with A is for me to shade it. And that means it is not complete. So it's going to carry the complement since only this one, completely only this one is shaded. So that's why it is carrying, I mean, the only this one is shaded, then it is complete. So which one are we to look for the complete shaded and the shading portion? B. So it's going to carry prime. So this one is shaded because this one is not carrying prime because it is shaded. So this one is not shaded, it's going to be carrying prime. So let's suppose that it is this one that is shaded. So then at this junction, A will be carrying prime. If only this one is shaded, this one is not shaded. Then the in between them is now our A intersection B. Well, when you add it together, we give you the value for this one. So this one satisfies the actual value of A. Like when you have A intersection B prime, it satisfies the actual value of A, like the exact value of A. When you have A prime intersection B, it satisfies the exact value of B. Then when you add the exact value of A plus exact value of B plus they will give you the actual value that should be the intercept. Unlike when you have a question that they just give you the initial, the allocation A is this, B is this. Those ones are just a temporary figure because at the end of the day, if you add those ones that came in the question, it will be more than the intercept. But you have to find exactly A, exactly B, and exactly A, exactly B, and add it up with the union. The intersection. Then you can be able to satisfy the condition of the universal. Alright, that's why I came about that. So now suppose this is this. So I told you that your plus is your union, your plus is your union. So we can just gladly change it here. So that's A union B is equals to A intersection B prime union A prime intersection B union A intersection B. So this one can be your equation. Let's make equation star one. Alright. So but from this circle now, for instance, from this circle, I'll be using the circle to generate other things. Oh shit. I'll be using this to generate other things here. Jesus Christ. So if I was told to find exactly so from this diagram to generate my exactly exactly is A intersection B prime. It was this circle is meant for A, right? This is the expression for exactly A. Whenever you have a Venn diagram, this is the expression for it. So exactly how will you now get the formula to use? That will be this is the circle of A. We are talking about A. That will be A minus the intersection, because this intersection we have A and you have B there. So the value you have for A, then you subtract what you have for A. At least we are having 10 and we're having 5 here. We're having 12 here. So you have to subtract 5 from this one to give you exactly. You have to subtract this 5 here from this one to give you exactly. So the exactly A representation is equal to this circle of A minus the intersection. That's A intersection B. So the expression for this one, but the expression for this exactly is A intersection B prime is equal to A minus A intersection B. So we can make this one equation 1. Okay, but exactly B, what's the expression? A intersection B, which one carry prime? A, because we are talking about B. So exactly B representation is this, and equals to B minus still A intersection B. You remove this one from this one. So then you now write it here that A prime intersection B is equal to B minus A intersection B. So this is our equation 2. Okay, so no stress. So at this junction, what are you now going to do? So what you do is that you are going to substitute equation 1 and 2 into equation star 1. So plug in equation 1 and 2 into equation what? Into equation star 1. I'm done with this. So at the end of the day, so I won't be able to continue down because I moved the camera close. At the end of the day, when we plug in this one, that is anywhere you see this one inside this equation, you substitute this. Anywhere you see this as well, you substitute this. So at the end of the day, you're going to be having A, then A union B, and this A union B equals to what is our A intersection B prime? Our intersection B prime is A minus A intersection B. Okay, union what's our A prime intersection B? B minus A intersection B. B minus A intersection B. Then we have substituted this. Then this follows union A intersection B. So you can see that's it, we are done. Then you have what? Proved. You have proved. It's very short, very short. So this is the proving of this first one. Some of you will be like, this proving is simple. It's very simple. This is the shortest one. Very simple one. So now I believe you understand it now. So we are moving to the next question now. I'm moving to this next question. So I'm going to be rubbing it off. You don't have to stress yourself. You understand? So you don't need to stress yourself. All these works are easy all the time. Alright. All these works are very easy. Alright, so solution now. So now, given that the root of the equation, what is the equation? X squared minus x minus 1 is equals to 0. So this is the given equation. Okay, the root are alpha and beta. Find in its simplest form. Find in its simplest form the equation, the quadratic equation with numerical coefficients whose roots are this. So we want to find in the simplest form what will be the root of this one. But the first thing you should do is finding alpha and beta. Finding the sum of root and product of root. They have given us that the root initially was alpha and beta. So let's find our sum of root and product of roots. But before then, you have to know that our a is equals to coefficient of x squared is 1, our b is minus 1, and c is minus 1. So our sum of roots, these are the roots they give us. What do you mean by sum? You add. So let's add them. Sum of the roots, that's alpha plus beta. Then literally the alpha plus beta formula is minus b over a. So what is minus b there? And what is b here? So minus 1 divided by what is a? 1. Then at the end of the day we have 1. Minus and minus 1. 1 divided by 1 is 1. Now our product of roots. Product of roots is alpha beta, right? So alpha beta is usually c over a. So what's c here? Minus 1 divided by what's a? 1. Then this one is minus 1. Okay, so that's it. So now, since we have gotten our sum and product of roots, then we can now talk about this. Alright, so we are going to insert the quadratic equation with numerical whose roots are. What will be the quadratic equation for this one? So you will now recall that in your secondary school they gave something like x squared minus sum of roots, sum of root x plus product of roots. You will remember very well, equals to 0. So this is another root they gave us. So we are going to solve for it here. So when you talk about the sum of roots here, minus what are the roots? This is the first root, this is the second root here. So you sum it, that's the meaning of sum. So let's input it here. 1 plus alpha over 2 minus alpha plus 1 plus beta over 2 minus beta. You sum this root, that's the meaning of sum. Then you put your x back plus the product of roots, you times it. The product is 1 plus alpha over 2 minus alpha multiplied by 1 plus beta over 2 minus beta. No stress about that one. Alright, so equals to is 0. Alright, so are we together here? So now we have x squared minus into the bracket. What's our LCM here? Our LCM here is, okay, that is 2 minus alpha, 2 minus beta. Alright, so this one take care of this. We are left with 1 plus alpha, 2 minus beta. Alright, plus when this one take care of this, we are left with 1 plus beta into what? Into 2 minus alpha. Alright, you have to expand this, so that's just it. Plus when this one multiply this one, you are having what? 1, okay, this one becomes 1 plus alpha, 1 plus beta over 2 minus alpha, 2 minus beta equals to 0. Alright, so we are still expanding. So you can now come here that x squared minus when you expand this one. So when you expand, let us expand 1 plus alpha, 2 minus beta. Let us expand it. This one is going to be 2 minus beta plus 2 alpha. Hope there's no mistake here. Okay, which means this. Okay, this is 2, this is minus alpha, this one is minus alpha beta. Alright, so this one is 2 minus beta plus 2 alpha minus alpha beta. Alright, let's do the same for this. So we're having 1 plus, we want to expand this one, beta 2 minus alpha, that will be 2 minus alpha plus 2 beta minus alpha beta. Okay, so this one is, we are also having plus 2 minus alpha plus 2 beta minus 2 alpha minus 2 alpha, sorry. Okay, so over, we are going to expand this one, 2 minus alpha 2 minus beta, we are doing it together. We are having 4 minus 2 beta minus 2 alpha plus alpha beta, 4 minus 2 beta minus 2 alpha plus alpha beta. So we have expanded this one now, plus, now let's expand this one, 1 plus, sorry, this one is having x, so please don't omit it, 1 plus alpha 1 plus beta, what do you have, 1 plus beta plus alpha beta. Okay, this one becomes 1 plus alpha plus beta plus alpha beta over this same one you have here, 4 minus 2 beta minus 2 alpha plus alpha beta equals to 0. I've got this thing to occupy the space. Alright, so here we are having 1 plus alpha plus alpha beta over 4 minus 2 beta minus 2 alpha plus alpha beta. Alright, so here we now have that x squared minus, so here we can, this one plus this one is 4. Alright, this one is minus alpha, you know, let's take this one together, minus alpha minus beta minus alpha is same thing as minus alpha minus beta, Abi. So which you can write as minus into alpha plus beta. If you expand it, you are getting the same thing. So this is minus alpha plus beta. So we are trying to get things right. Alright, so now let's take these ones together. We're done with this and this, so let's take this one together, 2 alpha and 2 beta. Okay, 2 alpha plus 2, oh god, let me see, is there no mistake there? 2 alpha, okay, this one, alpha 2 beta and alpha beta. So it's alpha beta. So please correct that. So now from here, 2 alpha and 2 beta, that will be plus 2 alpha plus 2 beta, that will be 2 into brackets alpha plus beta. Okay, we have solved it. When you bring 2 alpha plus 2 beta outside, 2 is common. Now that I came about this, so I extracted it from this place. So we are done. So it remains, we are done with this, we are done with this, and this, we are done with this and this, it remains this and this. So minus alpha beta minus alpha beta, that is minus 2 alpha beta now, right? So over what? Over 4 minus, we can rewrite this one as 2 is common here, into alpha plus beta. Okay, if you expand it to get this back, plus alpha beta, no stress, this x plus 1 plus alpha plus beta plus alpha beta over 4 minus 2 into alpha plus beta and plus alpha beta equals to 0. Still the same thing. So now at this junction, we have been able to simplify it to the simplest form. So we now have that what? X minus 4 minus, what's our sum of roots? Our sum of roots was what? 1. So that's 1 plus 2 into 1 minus 2 into our product of it is minus 1. Okay, very simple. Then 4 minus 2 into 1 plus and minus is minus 1. This x plus 1 plus 1, then minus 1 plus and minus is 1. Because sum of roots is minus 1. So 4 minus 2 into 1 minus 1, okay, equals to 0. So we have x squared minus, you understand, 4 minus 1 plus 2 plus 2, okay. So now over what? 4 minus 2 minus 1, we have x plus, this one is 2 minus 1, this 1 over what? 4 minus 2 is 2, 2 minus 1 is 1 equals to is 0. So we're having x squared minus 4 minus 1 is 3, that one is 3 plus this one is 5, 5 plus this is 7, 7 over 2, 2 minus 1 is 1, I mean 4 minus 3 is 2, 2 minus 1 is 1, 5. So we have x plus 1 equals to 0. So we are having what? X squared minus 7x plus 1 equals to 0. So this is our final answer. So that is the equation they asked us to look for. The equation of this one is what? So we are finding the equation. So it's not hard at all. So I want you guys to just study it, okay? So study very well. It's not hard. Study it. So if there's any issues, you can drop it in the comment section. I remain my humble self, Eli Tutor. So don't forget to subscribe. Tell a friend to tell a friend. I love you all. Please, please, we have a coaching center like not far from now. So in case you are an indigent, you base there, please do well to refer people to us. So JAMB class, UTL, what's it called, SSC, WAEC, NECO, and everything classes. We also have one situated at Ibadan, our one side. So in case you have people around there, so please do so to refer people to us. We run admissions, we do any form of registration, and our result speaks. We love you guys.